Hello, good afternoon everybody. Malinaw ba ako? Malabo? Mahina?
Good afternoon po. Yes po.
Audible naman.
Dinig po, ma'am.
Ay, good evening. Good evening na ba? Good afternoon. Nice to see you again, guys. Kumusta ang inyong break? I hope you have recovered a bit or have taken time off and are now rested. I did. And so I'm eager to share with you yung ating new lesson today. All right. So let's go and do that, shall we? Ito, wait lang ha. Ayusin ko lang yung share ko. Not this. It's the other. This. Okay, game. Share the slides and let's go through the items in the slides. Okay. Okay. Alright. Yung utang kong topic, dapat nung Holy Week ko binigay ito, pero as you know, may break, makakalimutan ng lahat. So today na lang. So our topic for video, next topic for video is video compression. Now, when you have a video, the original or analog videos are actually still images, no, saved in a roll of film. And when they are projected in rapid succession, they give the impression of movement, right? So in the traditional films, the old films are done this way. Now, the current technologies now allow us to save these images in hard disks, right? Or in media storage. So digitized na and then save. However, these are actually kung image per image ang pag-save mo. But actually we can do that now. Our cell phones, our smartphones can save bursts of images. When we go live, when we take a image and it's live, it's actually a burst of image captured. But saving a whole film or a whole long clip or even transmitting video information, doon papasok yung necessity of compression. For example, in the use case of surveillance cameras, no? So from the camera side, it will be digitized and it needs to be, the video need to be transmitted, all right? And then, or rather digitized, encoded, transmitted, and on the receiving end, it has to be decoded and displayed. Okay, kung kailangan mo ng real-time streaming, ganyan, or such, dito importante yung compression. Okay? So also saving. So two things, no? When saving video, better it be compressed kasi masyadong malaking resource ang kailangan kung you will save it frame for frame. And in real time or in streaming applications, kailangan compressed siya para ma-transmit siya at ma-decode siya rapidly. Okay? So, how does it work? Marami actually video codecs. Codec stands for coder decoder, but we will discuss the most widely used video codec. Widely used kasi Apple, Microsoft, Adobe use this. So it's widely industry accepted. All right. Of course, there's actually H.264, H.265 actually already, but it's still not widely accepted. So let's talk about H.264, the codec of the moment. It's also known as MPEG-4. Okay. Of course, when you have video, you have temporal information and audio information, but for this discussion, we will exclude audio compression, shall we? Okay. How does it work? Di ba nga, pag kumapture tayo ng image, we have perhaps CCDs, and it can be a 3 CCD camera. So there's a channel for each of the red, green, blue. Convert a red, green, blue frame or image of the whole video first into CRCB. This is a color space similar to hue saturation value because it converts RGB channels into luminance, which is the brightness of the image, and chrominance along the red-green, and chrominance along the blue-yellow, right? So, pero when combined together, you can recover once again the original color. This is just another representation of color. So there are matrices that can convert RGB to YCRCB and vice versa. And then, dito pa lang nagsisimula ng compression. Kasi tayo, ika nga ni Imelda Marcos, perception is everything. Itong sa Y channel, the luminance, mas sensitive ang human vision or human observers to gray level or brightness variations kaysa color variations. Kaya one parameter when compressing is how many bits will you assign to the luminance part, the Y, versus the chrominance, CRCB. Sometimes 8 bits dito, 8 bits dito, 8 bits dito rin sa CB. But sometimes it can be done na 8 bits dito, 4 bits lang dito sa CR and CB because we won't notice it. Yun ang point nun. Okay? So dyan pa lang, pwede nang mag-compress. Alright. After conversion, the next step is, remember ha, di ba, kung imaginein mo, video, several frames yan, pictures. But this is what you do. You're gonna divide these frames into groups of pictures or GOPs. No? And the initial frame will be called the intraframe or the key frame. All right? And in between, usually itong mga keyframes, sila yung, kung kunyari, may isang scene tapos nagkaroon ng scene cut, meaning nagkaroon ka ng change of scene, di ba? So, pag meron kang scene doon sa video na pare-pareho lang sa yung background, etc., the first frame there would be the intra-frame or the key frame. Ngayon, kung kunyari nag-change ng background or nag-change cut yung video tapos punta sa ibang take, then that frame where the cut in the video can be the other key frame or the I frame. In between, you have either P frames or B frames. P frames are predicted frames and B frames are bidirectional frames. And how do they work? So ganito yan. So the I frames are the reference frames, kumbaga. Okay? So kumbaga all the other frames will be referred to this first key frame. Okay? Do you know how JPEG images how images are converted into JPEG or compressed into JPEG? Ganun ang gagawin mo sa iframe. To do so, say you have a video, you subdivide a frame of the iframe of that video, designated iframe, into 8x8 blocks. So for example, this is an 8x8 block in that big video. No? Now, for each pixel, by the way, you will subtract the value, digital number 2 raised to the n-1, where n is the resolution of the pixel resolution of your gray level. So kunyari, kung ang grayscale resolution natin is 2 to the 8, so 0 to 255, 0 to 0, kasi or rather there are 256 gray levels. Mag-subtract ka ng 2 to the 7. Or you will subtract the digital number 1 to 8 from every pixel. Why is this so? Para mas angat, para magkaroon ng positive and negative numbers. No? So parang meaning center mo lang siya. No? Inalis mo yung bias. Nag-alis ka ng constant bias, in this case 1 to 8. Why is this so? Because we will apply to this 8x8 1 to 8 subtracted block, we will apply the discrete cosine transform. Okay, so ano yung itsura ng discrete cosine transform? Remember, it's just like Fourier transform, except you just use the cosine part of the Fourier transform. Kasi cosine plus sine ang ang exponential dun sa Fourier transform kernel, right? Imaginein mo, tanggalin mo yung sine part because usually that's for phase and for the imaginary parts, etc. So, maiwan lang yung cosine. Why is this valid? Because images are all positive. No? images, walang negative sa isang image. But in this case, para litaw yung sinusoids and para mas efficient yung pagkuha natin ng coefficients dito, we will subtract, we will remove 1 to 8 bias para malaki yung mga numbers. Posibleng malaking numbers makuha natin dito sa mga coefficients na to. Because this is originally an image, we don't expect phase information. So enough na yung discrete cosine transform. This is how the discrete cosine transform basis look like. Okay? This is frequencies along the x, frequencies along the y, and combined frequencies along x and y, right? These are 64. All in all, these are 8 by 8. These are, and also each of these blocks are also 8 by 8. These are all the basis functions, the complete 64 basis functions of a discrete cosine transform. What do you do? Take, for example, this 8 by 8 block and take the dot product of that with this. You get a scalar that is the coefficient of this basis vector. If you can imagine these as basis vectors, okay? So for example, ito yung value na lumabas, no? Do it for all of these basis vectors here. Think of these as basis vectors, no? Take this, that product that with this image again. By the way, imagine niyo ito na yung minus 1 to 8, and then you get these coefficients and so on and so forth. Okay, there. So now you've computed the discrete cosine transform coefficients of this sub-image, this sub 8 by 8 block. Okay, what do you do next? Well, you quantize these real coefficients into integers. Remember, these are real numbers. You see there, these are real. These are real numbers. And one way of reducing the size of this is to quantize it and make it into an integer. Now, this is where the compression quality comes in, because you have the way to do this is by using a quantization matrix. Let's click this link, and this is how it goes. Okay, JPEG has provided a quantization matrix for different quality values. For example, this sample quantization matrix. What you do is kung ano yung coefficient nung basis na yon, yung isang basis vector, i-divide mo by this number and then round off. So yung magiging integer, no, kasi renound off mo, iyon na yun magiging bagong value. So for example, ito yung mga DCT matrix before quantization, after quantization, divide them by, so element per element, divide mo to by this number, by this number, by this number, etc. and then round off. Okay? So pag na-round off mo, ito yung mangyayari. Notice that may mga coefficients, ay may mga values kasi dito sa quantization matrix na malalaki. And mangyayari niyan, pag round off mo, magiging 0 na lang dahil a small number divided by a large number will become 0. Okay, and after the quantization, okay, makikita mo na mas marami ng zeros. Yan. Okay. Now, going back, kunyari, meron pa ng quantized, no? Yung real coefficients mo na quantized na into integers using a quantization matrix. Did you notice that kung titingnan mo yung mga values nila, medyo zeros na dito sa bandang dulo, no? So what you do is you save only those numbers, or rather you line up the values of the coefficients, the quantized coefficients, okay, in zigzag fashion. Hindi katulad nito, usually ganito yan, ano? Pag nag-concatenate tayo ng matrix, no, you do it in a zigzag fashion, just like this. Line this up, the second number will be this, the third number will be this, the fourth number will be this, the fifth number will be this, this. And why? This is because gusto mo equally makuha yung frequencies along X and along Y. Okay? This. Tapos titigil ka kung kunyari zeros na yung mga susunod. Okay? That would be the end of the coefficients. All right? So you were out of 64 possible numbers, because there would be a lot of zeros, you are left with a few numbers, and that is what you will send. Furthermore, since these are integers, you can have less bits to represent the values, the quantized values. Another trick to lessen the numbers. But that's the way to do it. So again, have a look. Let's go back to this, quantized coefficient matrix, no? After quantization, magiging ganito siya, no? And kukunin natin sila in this way. So ito muna, tas ito. We will line them up. That's why we're sampling them in a zigzag fashion. We will line up these numbers in one concatenated set of numbers. And then we'll just discard all the zeros after the sum. So meron, kunyari ito, hindi natin di-discard yung mga zeros dito, but we will discard after this. Yan na. There are many other ways. So if this is, kung medyo mukhang it's looking sparse, no, there are also other ways of cutting out further these zeros in this matrix after quantization. But that's the point. Medyo nabawasan nabawasan from 64, you just have a few numbers to transmit. Okay, back to the video compression. So essentially, JPEG mo yung iframe. Then what? Now, let's go to the pre-frame. Now, kung titignan nyo, so kunyari, nag-parse tayo ng video, di ba? We sometimes do that, if we want to take an image from video, we can parse it into bitmaps or JPEG. Now, if you take the difference between frame 1 and frame 2, or frame n and frame n plus 1, you will notice that pag hindi nagkaroon ng scene change, pag hindi nagkaroon ng scene change, the difference between a frame and the succeeding frame is very small. Mas maraming magkahawig between frames, no? Kaysa differences. So another way of compressing, another method to further compress, is you just take the difference between the keyframe I and the next frame. Hindi pa siya compressed, just take the image difference, okay? Y to Y, CB to CB, CR to CR. By the way, you are going to do this per channel, okay? Now, yung magiging difference image, iyon yung i-compress mo. Yun yung i-compress mo. Again, the idea here is that successive frames in videos within a scene, basta walang scene change, are highly similar, okay? Now, also within the P frames, there are other ways of further compressing information. Compute the motion vectors. You can divide the frame into, instead of 8 by 8, you can divide them into 16 by 16 macro blocks. Okay. And in the next frame, hanapin mo kung, the idea here is, pag may gumagalaw na, again, essentially we are now compressing temporally. Kanina, spatially, now we are compressing temporally. Nung pag gumagalaw na yung isang region of interest sa video, may parts doon sa region of interest na hindi naman nagbabago, right? Yung parang gumalaw lang siya ng location. So the computation of motion vectors is another way of compressing temporal information. So from these 16 by 16 macro blocks, titignan mo saan siya pumunta in the succeeding frames. And then you create parang optical flow ba? You create or estimate motion vectors of this macro block to where it went in the succeeding frames. Okay? The point of this is then you can just copy the macro blocks in the next frame. So na-save mo yung, say, alam mo yung macro block dito sa previous frame, hindi mo na kailangang i-represent siya ulit, just copy it in the next frame. Okay? So copying macro blocks in the next frame and moving the motion blocks, moving them to the new location according to the motion vectors, right? When you decode. So when coding, you just keep the motion vectors. So you compress the pre-frame by taking its difference from the keyframe. You compress the difference image. You compute the motion vectors for subblocks. You keep that motion vector. Therefore, when you decompress or decode the video, you have the keyframe, the p-frame, and where the motion vectors went. Okay. Now, then there are b-frames. Now, similar to p-frames, they are difference. They are made from the difference of a previous frame, but this time you also take the difference of it for the next frame. So ba future and past ang tinitignan mo when talking about B-frame compression. B-frames are only used when you are saving videos, say to MP4, no? But not for surveillance videos, because the B-frames are useful when searching or scrubbing through a video. Alam mo ba yung ibig sabihin ng scrubbing yan? When you're just scrolling through a video and looking for a scene which you want to cut or you want to edit. Okay? Yon. So B-frames are usually used when you now save the video. Okay, next. So the image is compressed. How do you decompress? So these are the frames and they are displayed in this order. So pag nagde-decode ka, so dinecode mo yung iframe. It's just like JPEG, no? So you display this frame. Then you have a P frame, which you also decode, but then you add it to the iframe. Okay? So i-add mo yung na-decode mo dito. And therefore, you will have a new frame here. Buo na yung frame nito. Originally, if you look at the P frame, it looks like mostly black because the difference between frames to frames are malaki yung similarity between frame to frame. So ito parang mukhang edge image lang to mga P-frames na to, right? So using the motion vectors and the P-frame decoded, you can now, and adding it to the keyframe I or iframe I, you can now form the image frame for this sequence, no? For this time in this order and this index. And then, so image na siya. So, siya naman yung i-refer nung susunod na P-frame. So, i-add mo tong difference na to dito. Pati yung motion vector at saka yung pag-move ng macro blocks and so on and so forth. Until there's another keyframe na dahil because there could be a scene change and so bago na yung iframe, and once again, that's it. So remember, the iframes are placed either in equal spacing, every 7th frame or every 6th frame, or kapag may large scene change. Okay? So dinidetect yan and ginagawa ng iframe, which is encoded just like a JPEG. And then yan. Okay? And this kind of decoding is essential. Itong walang, note this decoding, wala siyang B frame, ano? And ito yung case when you are sending video stream in a surveillance camera. Okay? So, sinend mo yung iframe, tapos sinend yung compressed P frame, tapos marirecover niya yung image frame dito sa second slot na to based on the iframe, etc., on so on and so forth. Okay. Teka, may chat. Sino may chat? Paano ulit nalalaman ng iframes? Hindi ko masyado na-follow. Remember, iframes are keyframes. They are at the start of the video or at the start of the scene. Okay? Sila yung reference frames kasi all the rest of the frames will be derived from it. Diba? Kasi nga, kaya nga, kinukuha yung difference frame per frame kasi masyadong magkapareho lang naman yung highly correlated ang frames in a video. Maliban na lang pag nagkaroon ng scene change. Scene change. What does scene change mean? Kunyari, take a look at any video. Kunyari, sa isang film, nagsasalita si Thor. Yung background niya, hindi masyadong nagmumove, ano? Yung mukha niya lang, yung bibig niya lang, pero yung background niya, steady lang. Kung, especially kapag still lang yung camera. Tapos, nag-move yung scene doon sa kausap niya. Okay, sino ba yung kausap dito? Si Loki. So, iba na yung background ni Loki. Siyempre, iba na rin yung mukha. So yun, the scene where Thor is talking, first frame there could be the iframe. And all the rest of the frames, just before Loki's scene comes in, can be derived from that iframe. Malinaw ba? Okay. Tuwing may scene change.
Thank you.
Ngayon, ang twiste nito, ang idea niyan, dapat hindi masyadong gumagalaw yung video. Di ba? I mean, hindi masyadong gumagalaw yung elements dun sa video, maliban na lamang dun sa actor or what have you, or objects that indeed are moving. Like in cars, in videos of traffic, the roads, in surveillance cameras, no? The roads do not change, but the cars do move, okay? So the scenery doesn't change too much. Maliban na lamang kapag sports video. Pag sports video, may panning, may zooming, di ba? Tapos malikot talaga kasi hinahabol mo yung movement ng mga athletes, ganyan. Kung ganon, maraming iframe yan. Sobrang rami, halos sunod-sunod yung iframes niyan because the video or the background is changing all the time. Even a simple zooming would be a different scene altogether. Kasi kunin mo yung difference niya, malaki yung difference niyan. Kasi lumaki yung background or lumayo yung background. No? So in sports video or sports broadcast, medyo magkakalapit yung mga iframes. So in streaming, live streaming, ganyan yan. Walang B. Maliban na lamang pag isi-save mo. Ayan ba? Bakit gumagano'n? Yan. In decoding naman, or kunyari, nag-save ka ng video or may playback, dito nagiging reasonable na magkaroon ng B frames. Look at the sequence by which it is decoded. So, syempre, the first frame that is decoded is the I frame. The second frame that is decoded is a P frame. In between the I and the P frames, there could be several B frames. The B frames refer to the previous and the future frames. No? And nako-compute yung mga elements niya from an average of differences between the I frame and the P frames. How about this one? Tignan mo. Ito yung next na i-compute. Again, titignan niya yung previous frame, i-derive niya rin yung difference from the i-recover niya yung tsura ng frame dito using this I frame and a future frame. So forth. So you see the sequence of by which it decodes the frames. Yan. Okay. Yan. There. So that's how H.264 is or video compression is done. Images come all over the place. And then that's it. Now, ang kinainam lang nito is, ang tanong kasi is, can we, kasi di ba kunyari nagsistream yung video. So ibig sabihin, may optical flow kasi may motion vectors yung video. May keyframes. So posible nating malaman kung saan nagkaroon ng scene change. Alam niyo ba guys, ang current research ngayon is video search. Kumbaga, ang big thing ngayon, ang hindi pa na-answer or ang big research question ngayon, especially sa Google, na-solve na nila sa Google kasi yung image search, di ba? Sabihin mo lang, search ka ng image ng ng car or whatever descriptors you use. You can even use an image as an image search. Yun nga ginagawa ngayon sa mga campaign. Sasabihin nila, this scenery comes from this kasi sa search nila. Malas na lang kung highly similar yung dalawang images. Okay? Akalain nila galing dito sa scene na to. Okay? Or doon sa frame na to. Diba? You can use images in Google to search for similar images. So, still image search, kumbaga done deal na yan. Solved na yan. Very well. There is ImageNet, and you can also ask CNN, deep learning, and just look for regions of interest or labels in a scene. Sabi mo, saan yun may horse? Saan yun may horse na may kumakain na ng grass, na may mountain sa likod? You can tell these elements of the scene and then it can give you a picture just like that. Pero ang big issue pa rin is doing that for video. Imagine, you have a video na sasabihin mo ay hanap ka ng video kung saan nabangga, asan sa frame sa video, asan yung time doon sa video kung saan nagbanggaan itong dalawang kotse na to. Imagine, yun na lang yung iso-search mo, di ba? Yun na lang yung search term mo. Ang hirap niyan. I experienced that firsthand kasi imagine niyo, we're taking videos of coral reefs and kilometers and kilometers, thousands of kilometers of videos of coral reefs. Nakakapagod tingnan, especially if you're after looking only, kunyari, you just want to look for clips in the video where there are significant number of corals. Wala kaming magawa kung hindi scroll through the video, hours and hours of video, nakakaantok. But imagine if you can do a search like, go to the timestamp where there are corals appearing or where turtles appear in the frame. Imagine doing that. Yun yung current research problem ngayon. Paunahan yan. Google is trying that as well. Searching within a video. So since videos are compressed this way, can we use this information already? Kaysa rin sa frame, kaysa we can do that image per image, no? Pero medyo inefficient, di ba? Kasi imagine mo you be processing image per image, but what if you can work on the compressed part of the video, di ba? Searching for sections or for clips of where there's something happening. Ang hirap pa niyan, guys, kasi biruin nyo action. Kunyari, syempre, temporal ang video, no? What if ang search term mo is search for a singing lady? Di ba? Hirap niyan. Paano mo alam na nagsising siya? O di baka dapat, baka nagsasalita lang siya. So, dapat kasama yung audio cue. Di ba? So, yun yun. So, if you're looking for an image and video processing PhD dissertation problem, that's one. That's one possible one. Kasi mahirap siya. Okay? And it's a challenge still. Okay. I'll stop search here and ask if you have questions. Dilim na pala. Kumusta ba, guys? Nag-gets niyo ba? So, pero I have an announcement. I decide na dalawa na lang yung activity sa video. Dapat originally tatlo. I can't think of an activity for the compression, so i-combine ko na lang yung activity for this and for the last topic on video into one activity. So instead of 3 activities for video, we'll just have 2. Nabigay ko na yung first activity, no, where you explore using your video cam, controlling your video cam by code, by MATLAB or by Python. May tanong ba? May utang pa rin ako sa inyo. Yung tanong ni Christian, hindi ko pa nasasagot yon. Still exploring. Hopefully Friday, masagot ko na yon. Okay. Yung tungkol dun sa RGB to PCA. Okay. Going once. Any questions about today's lecture? Going once. Going twice. Gone. Okay. Walang tanong. Kung ganon, thank you very much for attending today's class and I'll see you next time.
Thank you, ma'am.
Okay.
Thank you
Ingat.
po.
Thanks, ma'am.
Ingat, guys.
Ma'am.
Thank you, ma'am.
Bye.